everyone. Welcome back to another update. I know I said the last one was probably going to be the last before the release, but a few things have happened, so a few more changes that are worthy of a new devlog, so I thought I'd do a quick one. Most of it, unfortunately, is stuff that's not going to look or show particularly interesting, but I'll go into some detail about the optimization work I've been doing. But there are some interesting features in the editor as well that I wanted to cover, just to show you what the editor is looking like as we get closer and closer to release. So I've got a list of things to go through to make sure I don't miss anything, so without further ado I'll get straight into the editor. So a couple of small changes around general UI consistency, trying to keep things familiar and constant throughout. So one of the things that two of the tabs were slightly different to everything else, so I've tried to bring them into line. The first one is the objects tab. Actually, if I load something up so that we've got something a bit more interesting to see. So we've got some, there we go, it's got some objects now. So I'll post a picture of what it used to look like up in the corner so you can compare, but basically before you had over here you had the objects list as before, but down here was a fixed panel for editing the properties of the object, and the sprite list that you can see here now was over at the bottom here. So I've expanded this right hand area out to give more room, both when you're working on animations but also more importantly when you're working on logic, to get as much space in there as possible, and move the sprites over to here for when you're setting up your animations. And the functionality that was before in the panel down here is now in a much more familiar pop-up, which is constant throughout the rest of the interface. So if you want to edit the object properties, you click on that or double click and it brings up a pop-up which allows you to set the same things that were exposed through a fixed panel down there. So it's just a consistency thing. Also I've set up across all of the tabs now this splitter paradigm, so everything where I've got multiple panels in there I try to put splitters rather than fixed separation. This allows you to lay out the interface as you want, so if you want more room for your sprites and less for your animation, you can do that. And before release I plan to store all of those UI layout decisions that you've made into a local file so that it's consistent throughout reloads, as well as the window size and everything else, so you can set out your interface as you like and keep that. So that's that one, a very small change, but again to keep things consistent. And similarly with the sprites, again I'll put a picture up of what it used to look like, but this one was probably the most inconsistent. So before, the main editing area, which is where you draw your sprites, was over to the left, whereas everything else is on the right, and all of the data and things that you use while you're editing the main thing were over on the wrong side, so they've been moved over to the left. And again, it's been set up now with splitters, so the functionality is all exactly the same, nothing's changed there, it's just a consistency thing. So things like screens, you always have the main editing area over here, data and stuff over there, so that's just a consistency thing. So hopefully that makes the interface feel a little bit more, it holds together a little bit better. So the other thing that I've been, the next thing I've been working on, which has taken up most of the time since the last update, and unfortunately it doesn't really, it's nothing much to show, but it's getting deep into the optimization of the engine to try and free up as much memory as possible to work on the Spectrum, which is obviously at a premium, and also at the same time to try and optimize performance where possible. So the area I've been focusing on up until now has been the logic VM. So for anyone who's been following along, at a certain point through the development of Kwyll, I switched from exporting C code from the logic trees, the logic graphs, so the node trees that actually control things like objects and other behaviors, and then compiled that with the Z88DK. The problem with that was it was impossible to predict how much space was going to be taken up, so it was very difficult then to give the game designer a clear picture of how much room they had to work with. So quite some time ago I switched to an alternative methodology, which is to implement a custom virtual machine, a simple logic machine on the Z80 on the Spectrum engine side, and then output assembly for that, effectively custom assembly for that VM from Kwyll, and then that assembly gets interpreted and executed on the Spectrum side. So this gives me a very consistent, or gives me the ability to give a consistent amount of space that's going to be taken up by the game. So that's a bit of a background about why the logic works that way. What it meant was coding all of the VM in C, which I did before, as a starting point, because it's the quickest way to get up and running, meant that you had a lot of space, a lot of memory taken up with the code for the VM, and so that's where I focused my time to begin with, and I've been working on that on and off over the last maybe 3 months, maybe more, hand coding each opcode in the VM, in the virtual machine, in Z80, translating the C code into Z80, and in doing so reducing it, optimizing it, and maximizing the space available. So I've completed it now. I think there's something like between 75 and 80 opcodes in the VM, and just looking at my data here, so the savings from the original starting point, just by hand coding the Z80, the opcodes into Z80, is 3063 bytes according to my analysis, which doesn't sound like a lot. It's 3K, but in the world of the Spectrum, 3K is really important, especially when you're working with games like this. But just to give you an idea of the change, it went from 5555 bytes, which is a very strange number, but it's the one, down to 2497 bytes, so it's less than half the size. But more importantly, during that time I actually introduced a couple more opcodes as well during that optimization, because I was working on other things at the same time. So it's not only reduced by half, but it does more. So the saving is quite significant. And just to give you an idea of where it goes from here, so that's a 3K saving, which gives you 3K more to work with when you're creating your game for sprites and so on and so forth, which is really important. But I've looked roughly through this morning before starting this video, and the engine code, the existing engine code, which is the code that I'm responsible for writing, so it's nothing to do with the Z88DK standard library, which I try to minimize how much of that I bring in, or the SP1 sprite library, which is what's responsible for drawing the sprites and graphics on the screen, or the BeepFX library, which is used for the sound effects. Nothing to do with that, which are all out of my control at this point. This is all code that I'm responsible for that runs the actual Kwyll game. So for things like moving objects, collision detection, changing screens, drawing the backgrounds, all of these things are all things that are coded in C by me for the Kwyll engine in particular. And the code at the moment that remains, not including the virtual machine, is nearly 9K, 8652 bytes. And then there's 350 bytes of engine data space used. So my plan going forward with the optimization effort is to go into the majority of those engine code areas and do the same thing I've done with with the Logic VM, which is to hand code at least sections of them where they're very expensive in terms of memory use, and pare them down to an absolute minimum for both memory use and performance reasons. So hopefully I can get a significant saving. If I can get half saving on the VM, I would hope to be able to get a similar sort of saving, maybe even more, depending on the nature of the generated C code in the rest of it, starting with important things like movement and object movement and collision detection, which are the key areas that need both looking at in terms of the amount of space that the code takes up, but also the performance implications. So that's where I'll be going, and trying to get eke as much out of that as possible. One more thing that I have done as a short experiment is to remove SP1's dependency on a dynamic memory allocator. So SP1 allocates memory every time you create a new sprite in order to store various data about that sprite, including the background information that it has to replace, and so on and so forth, and things like shifting and shifting of pixels. And it does that by default by allocating memory from the heap, what's called the heap, which is a general memory area that the Z88DK can make available, and it grows according to need until it runs out. But the memory allocation, the code for allocating memory in Z88DK's standard library is quite expensive, and this is the SP1 library is the only place in Kwyll that has to use that allocation framework, and it only allocates chunks in a very specific size. So you've got a very generic memory allocation framework being used for something that's very specific and very focused, and it's a waste. So an experiment I did actually while I was in the hotel at Zap 64 Live recently was to actually replace to fool SP1 into not calling the generic memory allocation routines, but actually to call a very specific, what's called a block allocator. So I can actually tell the standard library, here's a block of memory that's this big, and you can allocate chunks of this size out of it sequentially. And I know that those chunks are big enough for anything that the SP1 needs. And then it doesn't need to grow, it will only allocate as much as it can from there. The allocation strategy is much simpler, therefore the code to do it is much simpler, so you're saving memory there. And it means, finally, that's the last piece of the puzzle for getting a consistent and reliable amount of space you have to work in number, because I'll allocate that buffer for sprites at the start of the game, and it never needs to grow. It will never grow. It will only have that much available, which means now everything that gets exported and compiled is fixed. So I can actually look at the generated code and I can say, of the amount of memory that the Spectrum has available, this much is taken up by Z88DK's standard library, this much is taken up by the engine and SP1, and this is how much you've got left for the game, and that will be a reliable number. So finally, once I've done that, I'll be able to put in, if we look very quickly, go back to Kwyll, you got this memory number down here, and if I click on it, it does a calculation of how much exporting this game is going to take, but the question mark remains here, and that's because at the moment I don't have that clear number. So this will eventually, hopefully very soon, show 6039 bytes of however much you've got available, so you can actually, during your game development, start thinking about where you need to save, how much you've got left, how many more levels you can do, and so on and so forth. So that's basically the state of play on engine optimization, which is going to be a lot of the ongoing work until release now, just trying to get as much as possible out of there. The feature set in large part within the Kwyll editor is pretty much there, and I'll show a couple more features that I've added that sort of tie that off in terms of the final feature set for 1.0. So if I quickly go to those now, actually, I'll explain one of them. So basically, if we go to the logic editor, if I switch back to Kwyll again, if we go to the logic editor, so what the logic editor, I've shown it in a number of videos, so I won't go into what it does or how it works, but one of the things that's always been missing up until now is undo and redo, and I avoided that. Undo and redo works everywhere else, so when you're painting or using the rooms, the tile map editor, undo and redo all work perfectly there, but it's never worked in the logic, and I've sort of resisted putting that in because I knew it was going to be a bit of a pain. So I finally put that in. So now if you do anything in the logic editor, you've got undo and redo. So, and that applies to connecting, disconnecting, changing properties, adding, deleting nodes. The only thing it won't do is if you delete a node, it will delete all of the connections. If you undo that, because of the nature of the undo system at this point in time, if you undo it, it will bring the node back, but it won't refix the connections. So that's going to be a manual fix up. If I can work out a way of doing that for 1.0, I might. If not, it might have to wait until 2 or the next release. So that was that. So now you've got undo and redo throughout the whole of the editor, as far as I'm aware. I don't think there are any more places where I haven't implemented the undo redo logic. So that gives you a little bit more peace of mind when you're working, that changes aren't necessarily permanent or problematic. But on to the interesting stuff. So one of the things that the users on Patreon have been asking about a couple of times is loading screens. So I knew it was something I was going to have to look at. I know the Z88DK has the ability, in fact specifically the tool that comes with Z88DK that packages up a binary into a .tap file for use on your emulator or on your device, has the ability to add a loading screen. So rather than actually go into too much at this release in terms of adding functionality to draw and create your own loading screens, I've just decided the best thing to do for 1.0 is to add the ability to load images from external sources, specifically .scr files, which is a common Spectrum file format, which basically is a dump of the memory. So I've implemented a loader in Kwyll that can load a .scr file and display it. So it'll display it in here with all the limitations of the Spectrum display, with the attribute clash and so on, so you can see exactly what it's going to look like. The idea being that there may be multiple screens that you could load. So an example of where that might be useful, when we wrote, or when we created Driller Incentive when I was there, we had a loading screen which loaded at first as is typical, and then the code loaded, and at the end of the code loading we loaded a second screen from tape, which was the Driller console, the Driller surround, which loaded straight into the screen like another screen, and that meant that we didn't have to have all of the memory for that complex background stored in memory. It did mean that you could never move away from that console, so all the menus and everything else were done within that console, but it's a useful way of maximizing space. So at some point I will allow other loading screens in here excuse me, and the ability to choose when to load them from disk and so on, but for now it's just the loading screen tab, and you can click to load a. So if I load this one, I think of all the screens I've loaded to test, this is the one I'm kind of allowed to show, and that's because I created it. So this is something that I drew for the release of Driller on the Spectrum. That's my name down there. So you can see it does all the color clash and attributes and everything, so it'll show you exactly what it's going to look like. If you now export this game with that screen, it will apply it to the loader. But let's load something a little bit more appropriate, if I can find it. Yep. Something that I drew. So this is me just tinkering in ZX Paint. I think it's called ZX Paint. Importing the Kwyll logo. So now if I export this, just to show how it might work, if I export this to my disk. Okay, and then if we switch quickly to the emulator view, and then open that export, which is on my desktop, I think. Yeah, it's very quick because it does fast loading, but you can see it loads that. And if I was to do the slow it down and run the tape normally, you get all the usual effects and you get the screen loading in the background. So that works. So basically that just gives you the ability to bring in externally created screens for your loading screen. And then the last thing I've done, which has been a bit of quite a bit of work. So if you've seen the preview window before, you'll notice some changes here. So prior to this, we had the main preview area, which is the Spectrum screen effectively. This is a data panel which shows when it's running, and this is new down here. So one of the things that I've had to work with the early adopters a lot on is working out why logic isn't doing what it should be doing, and quite often I find myself struggling to identify the problem myself, even though I have deep access to the source code and understanding of the logic. So prior to release 1.0, I've wanted to put some sort of basic debugging capability in there. I didn't know until I started how much I was going to be able to do realistically, but it turns out that I've managed to get something which I think will be quite useful and can be grown over future releases. So basically the way it works is in your logic editor, which wherever that may be, so some of the rooms have logic too. Let's see if this one has. No, none of these rooms do. Okay, so that's fine. So we've got the logic on these objects, and you got logic on screens and on global logic as well. In any of those, if you right click on a node, so let's go down to, so this down here is the shooting logic, so the player can shoot a bullet basically. Sorry about that. Bikers. So now you can select any object, any node, and before you had a couple of things in here, but you've now got this breakpoint. This breakpoint option. If you click on that, you can see that it puts a little marker on here, and that's consistent. So you can see, you can go looking through your node trees and see where you've placed breakpoints. At the moment, that's the only visual indicator. So what will happen now is when this code, this flow here gets executed, and this node is reached, the preview will stop there and let you do some investigation and explore what's going on. So if you have a problem with your logic, you put a breakpoint where you think something's not quite right, and what you do is you go to the preview and hit play. So now everything's working as normal. I can play with the keys. Nothing changes, there's nothing happening in here, everything's working up here as normal. But the most important thing is, if you now, so I haven't actually got to the point of running the code where I put the breakpoint at the moment. That's why the game is playing quite happily. As soon as I hit the space bar, it will bring up the logic for the player. It shows you that it's in the player here, and jump straight to the node that you put the breakpoint on. It shows as green, which means it's the current node. But importantly, there's two states effectively for the node when you're in the debugger. It can be green like that, which means it's on the way in. The debugger has stopped the execution of logic before doing what this node does, whatever this node happens to do. So it's stopped just before it does anything. And then on the way out, after if you single step through, on the way out of this node, after it's completed all of its processing, it will turn blue. And the reason for that is if you now step, so you've got these two buttons up here, this one will just continue, so it just carries on until another breakpoint is hit. Or I can single step, which goes to the next node that the logic VM is going to execute. Now in this case, because this object, this node here, sorry, is requiring an X and a Y input from over here, what we'll see is as soon as I step, it'll step over to this node, because this node is providing the inputs that this node needs to continue. So if we single step, it'll go over to there. Now because this has no flow, it's just a data provider, it jumps straight to the output. And if we push forward again, it will stay in the same one, because it's now the spawn object is now requesting the Y value. So it's the second one going through. And then This is where it gets a bit strange. So the spawn, and this is why I chose the spawn node as a breakpoint to show this how this works. So you'll see that the logic has changed to D0. Now what that is that's a dynamic object. It has no name. When you create a sprite, when you create an object dynamically, it has no name. So I just give it D0 or D1, D2 up to 10. And what's happened here is the spawn node has created the dynamic object and then called initialize on it. So when you stepped to the next logical place that the engine is going to go to, it's actually going to jump into the bullet object, which is D0, and do its initialize. So if I step again, it steps into this set variable, and then it's out of there, and then we'll come back to the spawn object. So that was basically jumping to another file effectively, if you were thinking about a traditional debugger. Now you'll see that the spawn object has now gone blue, which means it's completed its processing, and you can see here it's created the bullet sprite. Now the other thing you have within within the debugger is the ability to examine some information about the nodes. All of the information up here, so if you're modifying variables or positions of objects, this will all update as you step through. So that's one level of utility. So if you're moving an object or changing a variable value, it will change in here as you change it and step through. But for a little bit more fine-grained control, if you right-click on a node when you're in the debugger, not only can you turn on and off the breakpoint if you want to, but it will show you the information about all of the ports on the node that you've right-clicked on. So this has two input ports, X and Y, which are 49 and 131, which are the results that came out of these green lines here. And then spawned ref is the output port, which currently isn't set, even though the node has completed its processing. It won't be set until someone or some other node requests it. So if we step forward again now, it steps over to this set object variable, again green because we're coming into this. This will now, if I step again, it will start filling in its port information and stepping through to wherever it needs to go to get that information. So this is going to step actually back to the spawn object to request that output. So if we step, it goes back to the spawn object, and now if I right click on this, we can see that the output port data has been filled in because it's been requested. So it's showing that D0, which is the bullet that was created. And then if we step one more time, the set object variable is requesting the value, which it will get from here. And we step again, and we're back in the set object variable. And this is showing D0 as the ref on the way in, which it got from the spawn object, and the value is 1, which is the facing, the value of the facing variable. So with this, you have a lot of flexibility and power to start looking into what's going on with your logic. If you create some logic and it doesn't do what you expect, you can put breakpoints, and you can stop things and inspect and see whether the data that you're getting in both the variables, the object positions, and on the inputs and outputs of nodes matches what you're expecting, and it'll allow you to hopefully easily debug any issues you have with the logic. So if we push play now, the logic will just carry on as normal. You saw the bullet fly across, and it won't come back in to the debugger until we hit another breakpoint, which will be when I hit the spacebar, and it'll come back into that one breakpoint that I've set. You can set and remove breakpoints in here, so I can set a breakpoint on there if I want to. So you don't have to do it. If I stop and go back to the object, you don't have to do it in here. You can do it live in the preview. And the difference is, if you set a breakpoint in a logic editor on an object, a room, a screen, or in the globals, that will be saved. So if you save now, the fact that you set a breakpoint on there will be saved with your project when you save next. So you can set up a bunch of breakpoints, save your project, go and have your dinner, and come back and carry on working on it, and that's fine. So that's the debugger. I think that's most of the features in for 1.0 now. I do have a small task list of things that I'd like to add before release, and they're all It's relatively minor, just nice to have sort of quality of life things like moving brushes in the room editor, some other bits and pieces in the sprite editor and so on that just make things a little bit more friendly and a little bit easier and efficient. So no major features, fingers crossed. I think all the features are in now, so that's what Kwyll is going to look like for 1.0 in terms of features. So as always, if you want to get involved, you've got any ideas, any suggestions, pop into the Discord. It's free to join. Anyone can come along and get involved in the discussion, and you're all welcome. I take a lot of feedback from a lot of people on there, and I hope most of the people on there will tell you that I am quite responsive to feedback. So if you want to see something in Kwyll, pop along. If you're interested in taking part in the early adopters program, pop over to the Patreon. I'll link all of these in the description below. And at the very least, if you like what you see, give us a like and maybe subscribe so that you can be informed when I do new videos, which unfortunately at the moment isn't very often, but hopefully we'll start to pick up a little bit with 1.0 on the way. Thanks for joining me. I'll see you next time.